Okay, this is the review of the Chapter 2 test. We're going to start off with number 1 and 2, naming the domain in range of this relation and determining if the relation is a function. The first thing I'll do is see if there are any repeat domain members, number -2, 5, 8, and 0. So this is a function. And the domain in numeric order would be the set -2, 0, 5, and 8. The range in numeric order would be -9, the set, -9, -4, 1, and 3. For 2 and 3, I'll check to see if these relations are functions. -2, 5, -2. Because -2 is the same domain member, produces two different outputs, so it doesn't pass the vertical line test. But I can name its domain in range, but it is not a function. The domain, which would be the set -2, don't need to repeat it, I've already included it, 0, and 5. The range in numeric order would be -9, -4, 1, and 3. Let's check out number 3. -2, 5, 8, and 0. So this is a function. No repeats of the domain. Now let's tell you what the domain is in numeric order. -2, 0, 5, and 8. And the range, the y values in numeric order, -9, don't need to repeat it, -9 is included, this -9, -4, and 1. Okay. Let's move on to function notation. The function f of x is 2x minus 9. The function g of x is the absolute value of 2x, then plus 3. What I need to find is f of x plus g of x. But I'm going to use 1/2 as my input for the f function, and I'll use -1 for my input of the g function. So I'm going to write down f of x first. So f of x is 2 times x minus 9. And I'll come back and fill this in with 1/2. Now I'm going to add g of x. G of x is the absolute value of 2 times an input plus 3. So 2 times 1/2 is 1, And now I have 1 minus 9 plus my input here was negative 1, and this is an absolute value. So this now is the absolute value of negative 2 plus 3. 1 minus 9 is negative 8. Plus the absolute value of 2 plus 3. The absolute value of negative 2 is 2 plus 3. This all equals negative 8 plus 2 plus 3 is 5, which equals negative 3. Now let's do f of x divided by g of x. So I'm going to set that up. I'm going to use negative 2 as my input for f of x. So I'll put in now 2 times the quantity negative 2 minus 9. That is f of x. Divided by g of x, which is the absolute value of 2 times 3 plus 3. I'll evaluate the numerator, then the denominator. 2 times negative 2 is negative 4 minus 9, divided by the absolute value of 2 times 3 is 6 plus 3. Negative 4 and negative 9 is negative 13 over absolute value of 6 is 6. So we have 6 plus 3 is 9. So it is negative 13 over 9. Find the constant of variation for each direct variation, where y varies directly with x. Then find the value of y when x equals 1/2. So it's telling you that these are direct variation equations. Remember, the direct variation is y equals kx, and k being the constant of variation. So when you have y equals 3, you have x equals 5. So I'm going to set this with the direct variation equation, y equals kx. I do not know k. Y equals kx means I substitute my value for y. I do not have k, that's what I'll be looking for, and I do have my x, which is 5. So let's find out what k is. K is going to equal 3 divided by 5. That's how I get rid of 5, is dividing each side by 5. So I know k is 3/5. So let's find the value of y when x is 1/2. This is my constant of variation. I can rewrite this now for the constant of variation, which gives me the direct variation equation for this problem, which would be y equals 3/5 x. I'm given x equals 1/2, so I'm going to use that to find y. Y equals 3 over 5 times 1/2, which equals 3 over 10. So y equals 3 over 10 when x is 1/2. Let's solve this for number 7. I must do the same thing with setting up number 7. Y equals kx, which means y is equal to 2/3 equals k, and then x is 1/4. I need to get rid of 1/4. In order to get rid of 1/4, I need to multiply both sides by 4. And then I will have 8/3 equals k. Therefore, my direct variation equation for this problem will be y equals 8/3 x. Now let's find out what y is if x equals 1/2. Y equals 8/3 times 1/2. I can either multiply this through and then simplify, or I can see that 2 goes into 8 4 times. So y equals 4/3 when x equals 1/2. Let's find the slope of each line. Remember, the slope equation is m equals y2 minus y1 over x2 minus x1. So this means the slope is -7 minus 4 over 5 minus a minus 3. That means we have -11 over 8. So m equals, or the slope equals, -11 over 8. Now find the slope of the line perpendicular to this equation. I know the slope of this equation is 1/4, but I need to find the slope perpendicular to this. If it's perpendicular, it must be the opposite sign than the reciprocal. The opposite sign of this would be negative because 1/4 is positive. So I will have now a negative number, and the reciprocal of 1/4 is 4. So m equals -4. Now I'm going to use the slope-intercept form to write the equation of the line with the given slope through the given point. Because I have a point and a slope, I can put this in point-slope form. Then I can rewrite it in slope-intercept form. So it wants you to write it in slope-intercept form, but I'll use point-slope form. You can alternatively use the slope-intercept form, but you'll need to solve for the y-intercept b. But I'm going to use the point-slope form, which is y minus y1 equals m times x minus x1. This being my x1, this being my y1, and this being my slope. I'll substitute the values of y, which is -1, and then m, which is -5, and then x is 1/4. Now I'll multiply through. This will be y plus 1 equals -5, x plus +5 over 4. Now I must move this 1 over, but I'll notice I'll have to subtract it from 5 over 4. So I want the same denominator. So if I subtract 4 over 4 from this one, turn 1 into 4 over 4. So I'm going to subtract 4 over 4, which is the same as 1. That will give me y equals -5x. And then this is 5 minus 4, which is 1/4. So that's slope-intercept form. Now, alternatively, you could have used the slope-intercept form for both, but you'll have to come back and find the y-intercept. So I'll show you how to use the slope-intercept form even when you're given a point in the slope. But I would still recommend to use the point-slope form because it's more straightforward. However, I can use y equals mx plus b, which the problem requires you to write it in slope-intercept form. So it will be in that form when I'm done. So I'll substitute what I have for my y, I'll substitute what I have for my m, and I'll substitute what I have for my x. That will leave us with the variable b, which is the y-intercept, which will be fun because then when I find b, all I have to do is then write it in slope-intercept form. I'll have the slope and then the y-intercept. So my y value is -1. My slope is 1/2. My x value is 3. And that leaves us with b. That gives us -1 equals 3/2 plus b. Now I'll solve for b. Once I solve for b, I'll have the y-intercept and the slope. So I'm going to subtract 3/2 from both sides. In order to subtract 3/2 from this side, I'm going to subtract 3/2 from this side, but I'm going to turn 1 into 2/2. That will give me the same denominator. So now what I really have is -2/2, which is 1, this one right here, minus 3/2 equals b. So b will equal to -5/2. Now I just substitute those values in the slope-intercept form. Y equals my m, which is 1/2, x minus 5/2. Use the slope-intercept form to write the equation of a line through each pair of points. Here I need to find the slope, and I can use the point-slope form, or I can use the slope-intercept form. I'm going to use the point-slope form, but first I must find the slope of this equation. So m will equal 4 minus 0 over -3 minus 0, which is -4/3. Now I could use either one of these points. I'm going to use 0, 0 because some things will cancel out then. So point-slope form is y minus y1 equals m times x minus x1. And then I'll convert it to slope-intercept form, y equals mx plus b. But because I'm using 0, 0, you'll see some things cancel out, so I'll automatically go to y equals mx plus b. So y minus y1, I'm going to use 0, 0 here, equals m, which is -4/3, times x minus x1, which is 0. So you can see all I have left over is x here and y here. It will already be in slope-intercept form. My y-intercept just happens to be 0. I'll do the same for number 13. Let's find our slope. M equals -8 minus 5 over 7 minus -2, which will give us -13. This becomes plus, so this would be 9. So here's my slope. I'm going to put it in slope point form or point slope form. That will be y1. I'm going to use this point. Really doesn't matter. I don't have 0, 0 like I have up here, which was convenient. So I'll use -2/5. But just remember, I just used one point. So I'm going to just cross out the other. I don't need it. So y minus 5 equals m, which is negative 13 over 9 times x minus negative 2. That becomes plus now. This becomes y minus 5 equals negative 13 over 9x plus negative 13 times 2, which would be negative 26 over 9. That must mean I bring 5 over to find my slope-intercept form. I'm going to have to turn this into a knot on the bottom, which means I multiply the top and the bottom by 9, which will be 45 on top and 9 on bottom. So I'm adding 45 over 9 to both sides. So I'm going to add 45 over 9, because this really is 5. 9 times 5 is 45, and I had to add it to get rid of this side. So now what I have is y equals negative 13 over 9 x, and then 45 minus 26. So 45 minus 26 will be over 9 though. So I have negative 13 over 9x. I'm going to have a positive number. So I'm going to have to borrow 1 from the 4, which will give me 3. This will be 9, and 3 minus 2 would be 1. That'll be a positive 19. Now I'm going to describe the translations as vertical, horizontal, or multiple, and then I'm going to graph each translation. If I look closely, this is the absolute value, which means y equals a times x minus h plus k. This is my horizontal movement. This is my vertical movement. My vertex for this one is going to be negative 2 and positive 4. It's negative 2 because the only way it would have changed the sign is if this was negative 2 to change this sign to a plus sign. So I know that I have a slide to the right, negative 2. And then I slide up 4. I don't have a value for a. Well, actually a is 1. So nothing happens to it. So I know it's going to look like this. So there are multiple changes. One is going to be vertical, one is going to be horizontal. I'm going to slide right by, or slide left, excuse me, by 2. 1, 2. And then I'm going to slide up by 4. 1, 2, 3, 4. So I know the vertex is there. You still need to know how to do a table on this. So be sure you know how to do a table based off the absolute value, the parent function. For number 15, there's only one movement, and that's going to be horizontal. There is no vertical movement. So I know my vertex is going to be positive 2, 0. So no vertical movement at all. Know your table again. So I move to the right 2 this time. 1, 2. My vertex is there. It looks like this. For 16 and 17, identify the A, the H, and the K, what it does, and include a table. So let's take a look at x plus 2, absolute value plus 4. I know A equals 1 here because there's 1 in front of the absolute value. So it doesn't open any differently than the parent function, the absolute value. It opens the same. But it does have a vertex of -2, 4. So I know H, the horizontal movement, is going to move the graph to the left 2. And I know K, which is the vertical movement, it will move it up by 4. So this will be no change, no change. This H will be slide left by 2, and then this would be slide up 4. So let's go ahead and do the graph. Okay. I know my vertex is going to be -2, +4. So that means my axis is x equals -2, 1, 2. So the graph is split evenly between -2. So I'll go up to now 4. 1, 2, 3, 4. And I know it looks like this, but I'm going to provide a table for you to make it easier. And then we'll do 17 on another page. So I know my x, I'm going to pick -2, 4 as my vertex, so I'll pick it right in the middle. And here's my y. That means if I pick the one right before -2 is -3, the one right after, which is -1, these two values for the y will be the same. Let's put in -1. If I put in -1 over here, -1 plus 2 is 1, absolute value is 1, 1 plus 4 is 5. So that must mean this one is 5, but I can check it out. -3 plus 2 is -1. Absolute value of -1 is 1, 1 plus 4 is 5. I can continue this. I could put -4 in, and then I can put 0 in. I'll concentrate on 0. It leaves a little bit easier. So I know 0 and -4 have the same y value. 0 plus 2 is 2. Absolute value of 2 is 2 plus 4 is 6. Should get the same thing up here. -4 plus 2 is -2. Absolute value of -2 is 2. 2 plus 4 is 6. Okay, let's do 17 now, which is -1/2 x plus 3 plus 1. Okay, so let's go to another page. Let's go y equals -1/2 x plus 3 plus 1. If I write the general equation for the absolute value, it's a x minus h plus k. I know here that it's a fraction and it's negative, so now I know it opens down. So a equals -1/2, which means it opens down, and it really is slow when it opens up. It's slow here. So it'll be slow instead of fast, which would be like that. And I know h must be a negative because it changed this negative to a positive. So I know h is negative 3. I know k is positive 1. So this means it slides left 3, and this slides up 1. My vertex will be negative 3, 1. That means my axis will be x equals negative 3. That's what splits it in half. And then I can build a table. I know my vertex, once again, is negative 3, 1. My axis is negative 3, 1, 2, 3. So that's where it splits this thing perfectly in half. And then I slide up 1. So I know my vertex starts there. And remember, I know this thing goes upside down because it's a negative. And it opens very slow. Okay? So I'm going to build a table first this time. I'm going to use my vertex as my middle starting point. So I know negative 3, 1 is my vertex. And then I'm going to pick the number negative 2, or excuse me, negative 4 before, and then negative 2 after. I'll start off with negative 2. Negative 2 up here, negative 2 plus 3 is what? Negative 2 plus 3. So maybe I want to start with negative 4. Or maybe I want to start with 5. That will give me something I can multiply a half by. Half of 2. So if I make this number a 2, it would be easier to graph because I'm going to take a half of it. How would I do that? Well, that means inside the absolute value has to be 2. So maybe I want to start off with negative 5 or negative 1. So if I put negative 5 here and negative 1 here, I know I'm going to get a 2. So negative 5 plus 3 is negative 2. Absolute value of negative 2 would be 2. 2 times a half would be negative 1 plus 1 would be 0. So put in negative 1. Negative 1 plus 3 would be 2. Absolute value is 2. Negative a half times 2 is negative 1 plus 1 would be 0. Again, I probably wouldn't go to 6 and therefore 0 here. I'd pick 1 up because that would give me something I can divide by 2 easier. So I'm going to jump by 2 here. So this is going to be negative 7. And the next one is going to be not 0, but 1. That will allow me to have a number that's easy to divide by 2. So let's do 1. 1 plus 3 is 4. Absolute value of 4 is 4. Negative 1/2 of 4 is negative 2. Negative 2 plus 1 is negative 1. Negative 7 then is the next one. Negative 7 plus 3 is negative 4. Absolute value of negative 4 is 4. Negative 1/2 of 4 is negative 2 plus 1 be negative 1. And then that completes my table. If you have any questions, please send me an email. Please also be sure to know how to graph two variable inequalities that we covered Thursday and Friday. Didn't even